In the last video, you guys understood about how to do substitution integration, correct? Now, in the last one, maybe you have seen one simple example. Let's solve few problems based on that one. Okay, normal substitution, nothing else, nothing more, nothing less. All right. Look at the first one. Find the antiderivative. Basically, integrate. The first one is x root of 1 plus 2x square. So in here, what we'll do is say I is equal to integral of x into root of 1 plus 2x square dx, correct? See, the whole point of this substitution problems is what do you substitute as t? Okay, now there is no one thumb rule as such, like, okay, this is what you need to keep it. It's not something like that. But there are different problems where you are going to have a different substitution. Fine. Now, the same problem, the first problem, I can give it to you in another way where the substitution might change. That's why substitution method comes only by practice. Just by looking at the problem as you keep on practicing, you will get to know what to substitute as what. Fine, it comes by practice. That's why we'll start with easier ones, then we'll go into the different type of problems. All right. See the first one, x into root of 1 plus 2x square. Now, a key point here, what you guys need to understand is that suppose if you have x square as t, assume, then 2x dx is going to become dt, correct? So what I'll write here, so I'm going to write 2x into dx is equal to dt. We already have an x dx outside. So yeah, well and done, case is finished. But it's not that easy, to be honest with you. The reason is inside the root you have a 1 plus 2x square also. So it's basically 1 plus some other, this one is there, coefficient is there for x square, right? That's why what we do, we don't just take x square as t. What if you take 2x square as t? Okay, suppose if you take 2x square as t, then you'll get, instead of 2x, you are going to get 4x. X dx is already outside, so you're going to get 1/4, correct? That's okay. But you have root of 1 plus. There is a 1 plus also. Right? Now, as you all know, derivative of a constant is 0. That means whether I add 1 here, subtract 1, it is not going to make any difference, correct? So, rather than taking just x square as t, you might as well take 1 plus 2x square as t. Because if you take 1 plus 2x square, then directly you are going to get 4x dx is equal to dt. In the sense, x dx is equal to 1/4 of dt. Correct? So, in place of x dx, you can put 1/4 of dt. So, the problem is going to turn into I is equal to integral of x dx is what? 1/4 dt into root of t. 1/4 is a constant, so keep it outside the integral sign. 1/4 integral of root t dt, or you can also call this as t to the power of half, right? Now let's recap. What is integral of x to the power of n? X power n plus 1 divided by n plus 1. Of course, plus c is there. That's not really that important anyway, right? So what we have, this is going to give us 1/4 of t to the power of half plus 1. Half plus 1 is 3/2 divided by 3/2 plus c, right? Now, this is going to become 1/4 of 2/3 t to the power of 3/2. Cancel. So 1/6. What is t? 1 plus 2x square. So 1 plus 2x square to the power of 3/2 plus c. So final answer is going to be this. Fair enough? So this is the answer for the first question. Let's do the second one. Here you have 1 by x in minus root of x, right? Now we can't directly take it. So here you have to think of an algebraic way of simplifying the problem. Before you directly apply, think of an algebraic way of simplifying. All right. So what we can do is, I can give you a hint here. Take root x common in the denominator. Yeah. So what you'll have, I is equal to integral of 1 by root x into root x minus 1. Now, before you further proceed, think, what if I take root x as t? Will it work? Or if I take root x minus 1 as t, will that be more easier to solve the problem? Always before you substitute and think, substitute and solve, think a little bit. Like, okay, is this going to be easier for me or is this going to be easier for me? Use that and then proceed. So for this one, what you have, of course, we have a dx here. If suppose you take root x minus 1 as t, then 1 by 2 root x dx is equal to dt. So dx divided by root x is equal to 2 times of dt. So dx divided by root x, 2 times of dt, right? So you're going to have I is equal to integral 2 dt divided by t, correct? Root x minus 1 is t. Now 2 is a constant, 2 times integral of 1 by t dt. 1 by t integral is what? Log, correct? 2 log of t plus c. Now log, you can write log of mod t. You know that log cannot be negative, so log of t is also good enough. So what is t then? T is root x minus 1. 2 times log of root x minus 1 plus c. So this is going to be the answer for the second question. All right, let's do the third one now. See the third one. There is an x square in the numerator and there is an x cube in the denominator. So I want you to think a little bit before further start with the substitution. Will you take x cube as t or will you take 2 plus 3x cube as t? So just to recap, look at the first one here and look at the third one. Both are algebraic functions itself. Just like what we did in the first question, you do the same thing for the third one also. That means rather than taking just x cube, take 2 plus 3x cube itself as t. Yeah. So here I is equal to integral of x square dx by 2 plus 3x cube whole cube, right? So in this what you do, take 2 plus 3x cube as t. You'll get 9x square dx is equal to dt. So x square dx is equal to 1 by 9 dt, right? Substitute. So you have I is equal to integral of 1 by 9 dt divided by t cube, correct? So because there is a whole cube too, take the 1 by 9 outside. 1 by 9 integral of t power minus 3 dt. So 1 by 9 t power minus 2 by minus 2 plus c. So minus 1 by 18 into t power minus 2 plus c, or minus 1 by 18 into, so we can do it that way or we can write it in a proper way. So proper way meaning what? Minus 1 by 18 into 2 plus 3x cube whole square plus c. This is going to be the final answer because there's a power minus 2, right? So it's going to be 1 by t square. So this will be the final answer for the third one. Let's do the fourth one now. See the fourth one? Guys, by now I think you will know what to substitute, right? Yeah, will you substitute only x square or 4x square? No, you just take the entire denominator as t. Yeah. So you have directly, I'll start. Okay, you know I is equal to this and all. Or if you want for maybe for this one, I'll write it down for you. X dx 9 minus 4 x square, right? So take 9 minus 4x square as t minus 8x dx is dt. So x dx becomes minus 1 by 8 into dt. Substitute directly in place of what? In place of this x dx, right? So you will have I is equal to integral of minus 1 by 8 dt divided by t, right? So minus 1 by 8 integral of 1 by t dt. So minus 1 by 8 log t plus c. So minus 1 by 8 log of 9 minus 4x square plus c. So this is going to be the final answer. Fair enough? So take normal simple log and you'll get the answer. Let's do the fifth one now. See the fifth one? X by e power x square. Very simple, take x square as t. Okay, so you can take it, or see, you can take e to the power of x square as t, but then calculation might go a little overboard. So let's do it this way. Hmm? So here, you can also do double substitution for this one. Let me show you that also. All right. Now what we have e to the power of, sorry, x divided by e to the power of x square. Right. So you need to do this one. First, what you can do, you can take x square as t. So 2x dx is equal to dt, or x dx is equal to half dt, right? So I is equal to integral of half dt divided by e to the power of t. Make sense? So you'll get this as half integral of e power minus t dt. Now you all know the integration of e power t, but you don't know the integration of e power minus t, correct? But we have e power minus t, so what do we do? Again, you can do substitution. So this is what I was talking about, double substitution. Yeah. So that means what we are going to do here, we'll do one more substitution. That is, say minus t is equal to u, another variable. So minus dt is equal to du, or dt is equal to minus du. That means this integral now becomes half integration of e to the power of u into minus du, right? So this will become half with a negative sign, half integral of e power u du. Now you can do this one. This will become minus half e power u plus c. But what is u? Minus t. Minus half e power minus t plus c. But what is t? X square. So finally this will become minus half e to the power of minus x square plus c. So this will be the final answer for the fifth one. I hope that you all understood how to do double substitution, right? First you substitute, you will get one variable, which again if you substitute, just to make things easier, you will get the answer. Just like how we substituted twice in this problem. Yeah. Now let's do the sixth question. Look at the sixth problem. See here, what you have is I is equal to integral of e power 2x minus 1 by e power 2x plus 1 dx. You can't solve it directly. Okay, so what you need to do is first you need to simplify and then do the substitution method. Okay, see, remember I was telling you there's no one particular thumb rule to solve any of the substitution problem. It goes by practice. By practice, you will get to know how to go about it. Okay, see, in this one, before you substitute, let's divide the numerator and denominator by e to the power of x. Okay, divide by this one. That means you will have integral of e power 2x plus 1, sorry, e power 2x minus 1 by e to the power of x by e power 2x plus 1 divided by e to the power of x. Remember, the integral is there for the whole thing. Now, individually divide. That means you will have e power 2x by e power x minus 1 by e power x, e power 2x by e power x plus 1 by e to the power of x. So, integral of the whole thing. So, what you will have I is equal to integral of e to the power of x minus e to the power of minus x divided by e to the power of x plus e to the power minus x dx. Right? Now what you do, take the denominator as t. Now, if you have noticed, in last all the 5 problems, whatever we have solved, we have taken the denominator as t, correct? So here, but that's not always the case. That's what I'm trying to tell you here. Not all the time denominator has to be taken as t. Even though in the majority of the cases you are going to do it, but not in every problem. All right. So you have e to the power of x plus e power minus x as t. So you'll get e power x minus e power minus x dx is equal to dt. So numerator entirely it's going to become dt. So you have I is equal to integral of dt divided by t, or this is going to become log of t plus c. So log of e power x plus e power minus x plus c. So this is going to be the final answer. Fair enough. This is the answer for the sixth one. Let's do the seventh one now. See the seventh one. See what you have. 2 cos x minus 3 sin x by 6 cos x plus 4 sin x. Right? If you notice in the denominator, you can take 2 common. Correct? So what you do, I is equal to integral of, or take half common. So half integral of 2 cos x minus 3 sin x divided by 3 cos x plus 2 sin x dx. Now what we do, we can take 3 cos x plus 2 sin x as t. Again, you might be thinking, again the denominator? Yes. The reason is, cos x derivative will give you minus sin x, and sin x derivative is going to give you cos x, which is there in the numerator. That's why. So you will have minus 3 sin x plus 2 cos x dx is equal to dt. The numerator completely becomes dt. So we have I is equal to half. Correct? Half is outside. Integral of dt divided by t. So this will become half log t plus c, or this will become half log of, what is t? 3 cos x plus 2 sin x plus c. So this is the answer for the seventh one, which is quite direct, I would say. Yeah. See the eighth one now. Let's solve the eighth one now. See the eighth one. You have I is equal to integral of x plus 1 into x plus log x whole square whole over x dx, correct? See, you have x plus 1 divided by x, this kind of thing. But you have a log function, right? So what you do, you take the substitution as x plus log x function, call it as t. So you'll get 1 plus 1 by x dx is dt, or you can write this as x plus 1 divided by x dx is dt. See this x plus 1 divided by x dx. This is dt, right? So you will get I is equal to integral of t square dt. See here, denominator we did not take it as t. That's what I'm trying to tell you. Not every problem you are going to take denominator as t. Alright. So you will get I is equal to t cube divided by 3 plus c. So I is equal to 1 by 3 x plus log x whole cube plus c. So this is going to be the final answer. Very simple, very, very simple problem, isn't it? That's all. Now let's do the ninth one. See the ninth one? See here, sine 2x is under the root, cos 2x is outside the root. Now think about it. Are you going to take sine 2x or cos 2x as t? Think about it. What is outside the root and what is inside the root? So if you look closely, then sine 2x taking that as t is going to make a lot of sense, right? So we have I is equal to integral of root of sine 2x cos 2x dx, right? So take sine 2x as t. So sine 2x as t. So you will get 2 cos 2x dx is equal to dt, or cos 2x dx is equal to half dt, right? So substitute this one. So if you substitute, you will get I is equal to integral of root of t into cos 2x dx, that is going to be half dt, correct? Take the half outside. So you will get this as half integral of root t dt. Root t is what? T power half, correct? So half integral of, half t to the power of t by 2 divided by 3 by 2 plus c. So half into 2 by 3 into t to the power of 3 by 2 plus c. Cancel off the 2 and 2. So you will get this as, you will get 1 by divided by 3 into what is t? Sine 2x. Sine 2x to the power of 3 by 2 plus c. So final answer is going to be this. That's all. Very simple. Very direct substitution. You will get the answer. Well and good. Let's do the 10th one now. 10th one. Here what you have, I is equal to integral of cos root x divided by root x dx, correct? Now take root x as t. That means 1 by 2 root x dx will be dt, right? So what do you get? 1 by root x dx will be equal to 2 dt, isn't it? So you'll get I is equal to integral of cos t into 2 dt, correct? Because this dx by root x is nothing but 2 dt. Keep the 2 outside. 2 times integral of cos t dt. So you'll get this as 2 sin t plus c, or this will become 2 sine of root x plus c. So this is going to be the final answer. Understood? So this is the answer for the 10th one. Now let's do the 11th one. See the 11th? Cos x by root of 1 plus sin x. Guys, by now I think you will get to know what you need to substitute as t, correct? Right? So in this question, you can take 1 plus sin x as t because you have a cos x in the numerator, cos x dx, correct? So you have I is equal to integral of cos x dx by root of 1 plus sin x. See, this is the value of I, right? The integral. Now you can take 1 plus sin x is equal to t. Differentiate. Cos x dx is equal to dt. So cos x dx is equal to dt, right? So you are going to get integral value I is equal to integral of dt divided by root of t, or I is equal to integral of t power half dt. Now it's very easy to integrate, right? So you will get t to the power of 3 by 2 divided by 3 by 2 becomes 2 by 3, correct? Plus c. So 2 by 3 into 1 plus sin x to the power of 3 by 2 plus c. See, this is going to be the answer. Yeah. So this is the answer for the 11th one. Very simple, very, very easy. Right? Let's do the 12th one now. 12th one is also very easy. Yeah. Let's do it. See, in this one, sine of tan inverse x over 1 plus x square dx. Now, if you take tan inverse of x as t, very simple, you will get tan inverse x as t 1 by 1 plus x square dx is dt, right? So dx by this is going to become dt. Now direct substitution. Yeah. So what you are going to get, I is equal to integral of sine t dt, because tan inverse of x you have taken it as t. So sine t dt. You'll get this as cos t plus c. Now what is t? T is tan inverse of x. So you'll get this as, oh, sine is minus cosine, sorry, minus cos t plus c. So do not do these kind of small errors in the tests and exams, all right? Be very aware of what is happening in the problem. So you'll have minus cos of tan inverse of x plus c. So this is going to be the answer for the 12th. Yeah, minus cos of tan inverse of x plus c. Now let's do the last, which is the 13th one. 13th one, you have integral of I sin x divided by sin of x plus a dx, correct? See, when you have sin x by sin of x plus a, you can't directly do it. So what we need to do is we need to do substitution twice in this problem especially. The first substitution what we'll do, we'll say that x plus a is equal to t, first substitution, or x is equal to t minus a, right? So in place of x, we put t minus a, and in place of x plus a, we put t, right? So the integral now becomes I is equal to integral of sine of t minus a divided by sine t, correct? Now, dx also you can take it. If you are going to take dx will be equal to dt. By now you guys can understand. See here, dx is equal to dt. So dt. Now, before you further do any sort of a substitution or whatsoever, expand the numerator and divide individually. In the sense, I is equal to integral of sin t cos a minus cos t sin a whole over sin t. Okay. Individually divide integral of sin t cos a divided by sin t minus integral of cos t sin a divided by sin t. See, in both the cases we have dt anyway. Sin t cancels. So what do we have? Integral of cos a dt minus integral of sin a into cot t dt. Correct? Remember, cos a is a constant, so you can just keep it outside. So you'll get this as integral of first cos a integral of dt minus sin a integral of cot t dt. Right? Now integral of dt is t and integral of cot t is log of sin t. Correct? So let's do the final part of this problem. Equal to cos a into t minus sin a into log of sin t plus c. Correct? So this, what you're seeing, is the final answer for this one. But you can keep it like this, but generally we don't, because we have to substitute t back into x, correct? So what we'll do, we'll take off this one. So first, what is t? T is x plus a. So you'll have cos a into x plus a minus sin a into log of sin of x plus a plus c. So this will be the final answer. Got it? So this is the final answer for this 13th question and the last one. Alright, so next in the next video, you guys will see about trigonometric identities and how trigonometric identities are used in solving the substitution integration problem. Alright.